This is the review session for project evaluation using rates of return. It's important to notice before we discuss rates of return that managers who have not been trained in corporate finance may not understand the details of net present value analysis, and they may just be accustomed to thinking in rates of return. So, such a manager may reflexively ask for a project's evaluation to be presented in IRR terms. Managers will have learned at some point that IRR needs to be higher than the cost of capital, and so they look at these as a possible area. It's not usually worth trying to convince a manager of the downsides of internal rate of return as a calculation method, so you need to know how to evaluate it. Let's discuss what IRR is. The internal rate of return is a calculation of the project's rate of return over time. That is, given some initial required investment, the IRR produces an estimate of the discount rate that would set the project's NPV equal to 0. That is, the highest weighted average cost of capital that will allow us to invest in the project. We do need to note here that IRR is a misleading measure because it assumes that managers will always have investment opportunities that are equally attractive to the project in question, and this is not something we can typically assume. The IRR is also not reliable when the project's cash flow signs alternate over the course of the project. That is, the first year we have a negative cash flow, the second year we have a positive cash flow, the third year we have a negative cash flow. Such series of cash flows would make our IRR invalid. Now let's go over several possible ways that we can calculate IRR. The first, and the one that may be most convenient in a corporate setting, is to use a spreadsheet. I'll be using Excel. You go through the process of estimating the future cash flows using Excel. These should be evenly spaced cash flows, usually annually, although they could be monthly as well. The first cash flow represents the year 0 or time 0 cash flow, what you require to get the project going. Now, if you've used Excel to calculate NPV, this is different. In NPV, the NPV analysis starts with the first year's cash flow at the end of year 1. The cash flow has to represent net cash flows each year. If there's some incremental additional investment that's required, like the investment in new net operating working capital or new equipment that's necessary to make the project continue to work, then you have to deduct these from the expected cash inflows in that year. It may be that a negative cash flow will result, and if this results in a change in the sign of cash flows from the prior year, then IRR cannot be accurately calculated. Now we use the IRR function. The IRR function requires the following inputs: the series of expected cash flows starting with year 0, and then an optional argument guess, which we typically won't use. Guess applies when there's a change in cash flow direction, but such a change would make the IRR calculation unreliable. And then, following the IRR accept or reject rules, we would accept any independent project that had a value greater than the required rate of return, or the WACC. And because the IRR assumes that the company can reinvest at the project's IRR, we can't use it to evaluate mutually exclusive projects. Sometimes it's more convenient to use the financial calculator. Using the financial calculator, we're going to use the cash flow function on the calculator to enter expected cash flows. Now we want to be sure that the CF0 entry equals the required initial investment, and it will be given as a negative number representing a cash outflow. And then we'll accept any project where IRR is greater than the discount rate. It is possible, but not easily feasible, to calculate IRR by formula. It either involves a trial and error method or more advanced manipulations. This concludes the review session for internal rate of return. Take a moment to attempt the problems in BB Learn and return for the next section, review of modified internal rate of return.